Well, all right. Well, I think I'm going to go ahead. I like to get started promptly. So, hello, all. I'm the Foundation's Executive Director, and I am pleased to welcome you to today's webinar. We appreciate your participation. I want to take just a minute to introduce our webinar moderator, Monica Buckle. Monica has served on the Mesa Verde Foundation Board of Directors for just over 3 years, and she has been graciously moderating our webinar series since its inception. Monica, take it away.
Well, thank you, Shannon. It's a real pleasure and welcome everyone. I hope you're enjoying the beauty of this fall season. And I also hope you have nice plans of being with family and friends for the Thanksgiving holiday. Today, we are fortunate to have Mike Rubin, Chief of Facility Management at Mesa Verde National Park. Mike will discuss how water is a vital resource and the topic of many conversations, especially in drought-affected regions. Have you ever wondered how Mesa Verde National Park gets its water? It's more complex than you think. The construction of Mesa Verde National Park's water system was completed in 1950. Today, 17 miles of pipeline delivers water from the West Mancos River to a water treatment facility near the park's entrance. From there, the water is processed and pumped to the top of the cuesta. Once the water reaches the top, it is delivered through 22 miles of pipelines to be used for domestic and operational uses and for fire suppression. Water rights from the Mancos River, Jackson Gulch Reservoir, and in-park sources grant 240 acres of water for parks use. The Facility Management Division of Mesa Verde National Park is responsible for operating and maintaining all built infrastructure. This includes providing safe drinking water to park visitors and residents. Snow plowing, trail maintenance, and construction are just a few of the many responsibilities the Facility Management Division is tasked with, and it is also the largest division within the park. Before we begin the webinar, I would like to make mention that the Mesa Verde Foundation is a 501c3 nonprofit organization and is the official philanthropic partner to Mesa Verde National Park. We solely rely on donations and the generosity of viewers and foundation members like you to keep our organization progressing forward. The foundation, sadly, has seen a decrease in overall donations this year, so we're counting on your support to help us continue our good work in 2024. A very special thanks to Alpine Bank, who will provide a match of up to $5,000 for year-end gifts, the 4th year in a row. This means that donations of any amount will go further. Anyone interested in making a tax-deductible donation can do so on the Foundation's website or by calling Shannon at the Foundation. Website and contact information is in the chat box. Lastly, with utmost gratitude, I'd like to give a special thank you to the park superintendent, Casey Cook Collins, for her invaluable support, as well as Mesa Verde Foundation's board chair, Jana Leslie. Now, circling back to today's presenter, Mike Rubin is the Chief of Facility Management at the park. He has worked in this position since 2017. He started his National Park Service career as an equipment operator at Mesa Verde National Park in 2010 to 2013. Mike went on to serve as Chief of Facility Management at John Day Fossil Beds National Monument from 2013 to 2015, District Facility Manager at Glacier National Park 2015 to 2017, before returning to Mesa Verde. Prior to the National Park Service, Mike served in the United States Navy, so thank you, Mike, for your service. I now would like to welcome Mike to the webinar. For viewers, please know that we'll take questions at the end of the presentation.
Thank you, Monica. And thanks to the foundation for all the good work you guys do. I've got to see a lot of it firsthand here at the park, so thank you very much. Well, I'm here today to talk about Mesa Verde's water system, and I'm going to share my screen with you here. I have a presentation that I prepared, so give me just a sec. Does everybody see that?
No, Mike.
Not yet. Okay. One more try here. Here we go. How about now?
Perfect.
Okay, so Mesa Verde National Park. How does the park get its water? Well, the way it gets its water now is a little different than it has historically, and it's evolved over the years from first becoming a park to where we're at now. I'm really excited to get to talk about this topic. It's something I'm pretty passionate about. It's something that we spend a lot of time and effort here on making sure that the park has safe water for our visitors and staff. So I'm going to use the acronym some MVF, but MVF is just for Mesa Verde National Park in the Park Service language. But Mesa Verde provides water for visitors and staff use, wildland fire, and structural fire. The park makes potable drinking water for roughly 500 to 150,000 visitors and staff yearly. With this water, we also protect thousands of cultural artifacts, numerous historic structures, and a vital built infrastructure with our water system. So as you see down here, we have a picture of the VRC, which houses a priceless collection of the park's artifacts, along with many other exciting special things that that visitors come to Mesa Verde for. And one of the ways that we protect this building and all the buildings in the park with that fire suppression systems is with the water that we make, and then also providing water for structural fire and wildland fire. So I'm going to give you just kind of a brief history of Mesa Verde water. I'm sure some of you are familiar with Lizzie Dickey, our cultural resource specialist. She's got great knowledge in the history of Mesa Verde water. So if you'd like to know a more historical version of the water, she'd be a great person to contact, or maybe do a presentation separately. But the brief history is as I know it, is that after the park creation, the springs that were used by the original inhabitants of what was the park then, of Mesa Verde, they used springs. So springs such as the Spruce Tree Spring were developed for park use, and as the park grew and we had more people and we're trying to develop the park, the springs eventually were not adequate. And so some large basins were created to catch rainwater. I'll have some pictures in a little bit here you'll be able to see, but some large catchwater basins. This was obviously well before water was treated and regulated for life, health, and safety. But so they catch rainwater and they use that for a while. And then eventually in like 30s, 40s, there were some deep water wells that were drilled. They ultimately failed supply and quality needs and just weren't sufficient for the development part. As Monica said, it wasn't until about 1950 that the current water system was designed and constructed as it is. And we'll talk about kind of the phases that water lines went through, but essentially the same intake, the same endpoints. That was originally developed around 1950. And it was completed around 1953 or 1954. But in 1979, a multi-phase construction plan, Mesa Verde Waterline Replacement Project, was formulated to replace the entire water delivery system from the intake all the way down to our points of use. And that big infrastructure investment, as I'll talk about quite a bit, has really kind of been the meat and potatoes of how we're able to afford to keep this water system running. These large scale infrastructure projects, mostly from Congress, or funding programs mostly from Congress. We have the American Recovery and Investment Act that I'll be referencing in 2008, 2010. And we were able to do a lot of this heavy phase, multi-phase construction plan. We're talking about these big replacement projects. Same thing now with the Great American Outdoors Act that was passed a couple of years ago. So I'll talk about kind of how we manage those types of large investments versus how we do day-to-day operations. So back to the history of the brief history of Mesa Verde's water. Many of you have been lucky enough to stay at the VIP quarters we have in the historic Chapin Mesa district here in our stone houses. We actually have a VIP quarters, which is quarters 8, and it looks a lot like a water tower. And that's because that's exactly what it was before our current water system. So as you see here, this picture on the left, they're installing the inside of the water tower in the building, and then they're remodeling it to turn it into a residence later on. So if you're walking around the Chapin Historic District and you see a water tower looking like building, It is now housing for VIPs. That's what it is. So where does the park's water come from? So Mesa Verde gets its water from the West Mancos River, uh, pretty far up into the San Juan National Forest. Park has actually the highest point of intake in the Mancos River Valley, and we are number 36 on water priority. So, being number 36 on water priority has not resulted in the park being without water, but certainly for the future, that's something that we plan for when we talk about conservation and sustainability of our water system. There's a few other water producers in the valley. There's Mesa Verde National Park, there's the town of Mancos, and then there's Mancos Rural Water that serves some of the county residents in the local area. So that raw untreated water is diverted from the river. It goes into a pipeline, and that pipeline really just gravity flows about 15 to 17 miles, depending on which survey you look at. And that begins flowing, like I said, out of the Forest Service. It crosses some Bureau of Land Management land, it crosses some Bureau of Reclamation land, and multiple pieces of private land to the park treatment facility located at the entrance. So while it's, we'll look at a map here in a second, but while it's crossing, all these various land managers or private lands, it's also going underneath the Mancos River twice. It's going underneath two large highways. It's going underneath the Jackson Gulch Reservoir's aqueduct for irrigation. So that really affects how we replace and work on this infrastructure, because the approaches we take are much different, if it's across maybe a desert BPLM section versus if we have to figure out a way to drill underneath a highway or a river without having too much impact to the river. So starting, in the National Forest, I believe closer to 8,500, 9,000 feet, it comes all the way down to the park at about 67 feet. So we end up somewhere around 700 pounds per square inch, which is a very high pressure. So that really affects the different materials that we can use. As those pressures are lower, we can use some maybe heavy walled HDPE type pipe that is maybe more cost effective and more suitable for those lower pressures. But as we get into those higher pressures, we end up using some very high tech, thick walled stainless steel. It's very expensive to be able to handle those increased pressures as we do the treatment facility. So here's the Mesa Verde water map, and mostly right now I'm going to talk about the raw water, so the water before it's treated, and we'll talk a little bit more about the system. But so that green line there is a Google Earth version of where the water comes from. So you can see way up here in the National Forest, we have our intake. Gravity flows underneath the Mancos River twice, comes up to Jackson Gulch Reservoir, goes underneath the Jackson Gulch Aqueduct, crosses many county roads where it finally crosses Highway 184 here north of Mancos, flows between Mancos and the park, and then where it finally crosses Highway 160 and comes across the highway and enters the park right about where that green, pink, and blue meet. So if you've ever been in the park and you get to our new roundabout that just was completed, instead of going straight to the roundabout, if you take a right, that is the park's water treatment facility. So we talk about where Mesa Verde's water come from. This is literally where it comes from. So this is our intake gallery on the San Juan National Forest, and what you can't see here is that up where my cursor is a diversion. So we have a head gate that diverts the water from the West Mancos River, and it flows into this intake gallery here. And so we can use these gates to control the height of the water that's in the intake gallery itself. And these two white pipes right here, you can see them in your picture, those are marking the end of our intake gallery. So we have a couple different intake galleries, but the intake gallery itself is really some perforated pipes that are underneath that stream bed that are allowing water to percolate from the stream through the stream bed into the pipes and then begin its gravity process back to the park. So our water operators that we have here at the park, we really like the water we get here because it's cold, it's clean. Like I said, it's the highest real intake for any municipality in the region, and it really makes our jobs a little bit easier to have this really nice, clean, cold water, because that minimizes the type of processes that we have to use to make safe water, safe potable water that meets all the rules and regulations that we're held to by the state and the federal. I won't talk about it too much, but the park does have a secondary intake, and that is at Jackson Gulch Reservoir. So let's say that maybe we had a really bad drought year and we lost water from this intake gallery early in the year. We could then draw that water off of Jackson Road. Same thing if we had a break maybe in between those places, we could switch our intake to Jackson Road. So it's nice having that secondary intake. But from the water treatment standpoint, the water in the lake, while we can make it potable, we can make it safe, and we can meet all the regulations, it takes more work, it takes more of a process to treat that warmer kind of stagnant water compared to this nice cold clear creek. So keeping this watershed cold and clear and is really important to the park and the water quality. So treatment and distribution. So raw water, as I said, it's treated at the facility located near the park entrance. Water is then pumped 8 miles to a 2 million gallon storage tank on top of Navajo Hill, which is the hill that the Farview Lodge is on. This water, if you're familiar with Montezuma Valley, this 8 miles of treated water flows between the park along our north escarpment for 8 miles, and somewhere around the fairgrounds / racetrack, the water then heads up the north escarpment. So what's kind of a marvel about this is that, until 2008, that water line was literally strapped to the escarpment. In fact, if you have binoculars now and you look at the right time of day, you can see the glint off of the old water line that was literally strapped with cables to the north escarpment of the park. It wasn't until about 2008, 2010, the project was completed where we actually directional drilled, and I'll show you some pictures here, but you're able to directional drill and put that pipe hundreds of feet below the escarpment. So if the escarpment's like this, we're able to basically cut that angle and drill all the way to the Navajo tank. So not great for water leaks to have a water line a couple hundred feet underneath sandstone, but we use some really, really good materials that will hopefully outlive most of the people that work on that into our children's and grandchildren. So that was a really exciting project. I'll show you some pictures here. But so, also the water gravity feeds 4 miles to our Moorfield tank, 12 miles to Wetherell Mesa. If you've been with Wetherell Mesa in the summertime, we have flush toilets out there. We have water for drinking. We have water for fire suppression. And 6 miles to the Chapin Mesa tank, which is where my office and the park headquarters is. After filling the tanks, water is distributed to points of use. If you are familiar with Mesa Verde and the cuesta, as Monica correctly called it, other than the Mesa, the cuesta really makes a great spot for gravity flow, because we have the high point of the cuesta where we have our 2 million gallon storage facility, which is really the heart of our water treatment system. And then from there, there's no energy other than gravity needed to flow that water down to all our different points of use. It can take over 30 days from water to reach the furthest points of use from the treatment facility. So that's from the time it's treated and it's pumped at 2 million gallon tank. By the time it makes it down to Wetherell Mesa, that could be 30 days or more. And so we have some real challenges when it comes to water treatment, because older water tends to build different byproducts. And so we spend a whole bunch of time making sure that we are testing and reporting and treating the water to meet all of our Colorado state and federal regulations. So if we wanted to fill up all these tanks that I've talked about, we could have we don't for various reasons, but if we wanted to, if we had to, the park has about 2.7 million gallons in storage capacity inside. So talk a little bit about our distribution. Our distribution is just everything that is after the treatment process. So if you look at that blue line there, the blue line is the water line is telling you that flows along the north escarpment of the park. It climbs up that north escarpment to a 2 million gallon tank where it flows downhill to Wetherell Mesa, Chapin Mesa water tank. It can actually backfeed with pressure to Moorfield as well, so it would backfeed back that 8 miles and then up the other 4 miles. But mostly we try to pump the Moorfield tank while we're also pumping to the 2 million gallon tank. But it's a little bit of an art, not a science. But we have the capability to do that. What does it take to maintain water at Mesa Verde? So we have 3 dedicated licensed water treatment operators. They do a ton of continuing education. They're constantly staying up with the new rules and regulations and a very extreme, vigorous testing procedure. So, and all this stuff is public knowledge on the Colorado Department of Health's website. You can look up our water record, and we really do have an impeccable record. And that's because of the knowledge and the dedication of our licensed water treatment operators. One of our water treatment operators has been here, I think, 35 years. And so, you know, he's very, very in tune with the quirks of the system and the improvements over the years. But really, there's just numerous support staff, and that's not just from the facility management operators. When it comes to these projects that we'll talk about here, you know, is the Park Service, you know, our mission is to preserve the resources and provide enjoyment, you know, in perpetuity. So we don't just go and dig up a water line and put a new water line in, because maybe that water line was put in before there was archaeologists in compliance, and it's going right through a documented site, which happens quite often. So it really takes a majority of the park staff to complete a lot of these projects that allow us to get water here. We have archaeologists that are surveying new lines, they're surveying old lines. We have biologists that are, you know, surveying for endangered species and critical plants to the park. And we have, you know, our IT guys are helping us all the time with our SCADA system and our reporting back, so the operators know what the levels of the water tanks are. So it really does take the entire park here to be able to provide water for visitors and staff and fire. So really, it takes the support of everyone for us to be able to just, you know, to have a flush toilet at the end of weather is actually quite a bit of work. The replacement value of our water system, you know, with inflation, this inflation is not added, so you could add what, 9% or so. But the replacement value of the water system is somewhere around $234 million, according to our latest system information that we have. It costs the park roughly $300,000 yearly just in operational costs. So that's just, you know, that's just park funded. That's things like treating the water with the treatment chemicals we use, filtering the water, replacing filters, small repairs, and testing. So the park really doesn't have the capacity to do much more than maintain the water system from a funding standpoint. So that's where we look to these large and small infrastructure investments to be able to keep this system running. So since 2020, I just pulled up the last 3 years using National Park Service fund sources. So, you know, basically all of National Park Service units have access to these funds, but we've been funded around $4 million to replace or improve Mesa Verde water infrastructure. So that's things like repaying water tanks, replacing sewer lagoons, and replacing sections of water. But with the costs of a lot of the material and construction, you know, $4 million doesn't get you probably 4 miles of water line in the middle. So that's where we really look to these large scale investments, like I've talked about, to be able to replace large sections of this pipeline as it ages and it reaches its lifespan. So I talked about the American Recovery Reinvestment Act in 2010. We have some really large scale projects in 2023, 2025, which is right now. We're actually in the design process through a fund source to Great American Outdoors Act, and we're being funded roughly $23 million in replacement of our aging water infrastructure. So that's the Moorfield water line and the Weatherville water line, and what that funding is slated for right now. And that's a large project, but when you have a $230-something million system, and you only can spend about $300,000 in operational costs, you really need these big investments in order to be able to keep this system running and providing water for park visitors and staff. So I'll talk about some of the projects here that I referenced. So this was an RF project from 2010. And those of you familiar with the park will recognize geologic overlook is right up here in this area. And this is the bend from geologic. And this is actually where the directional drill that came from the bottom of Montezuma Valley went hundreds of feet underneath this North Escarpment. It came out right here. So that was a large scale, I think $7 million project that was done. And it really improved our ability to provide water. Like I said, this section of water line is actually, it's still there, and the old section of water line is strapped to this escarpment over here. So there's freezing issues, there's leaking issues, there's rock fall issues. So this was a big improvement to directional drill this water line, and we haven't had, like I said, any leaks or problems with it since. So here's a project from 2018, and this is a little bit different approach. So this is on the National Forest, and this is a section that crosses the West Mancos River twice. So since the pressures are lower here, we can use a HDP flexible pipe, which is more cost effective. It's also really hardy, as I'll show you here in some other pictures. But so we're using heavy equipment to really just plow this right into the ground. They make a couple passes to break up the ground, and then they plow this HDP right directly into the ground. And when we come to the water crossings, then we utilize directional drills. The directional drill underneath the river so that we don't impact the river, and we're able to pull this this line through and weld it together and make a continuous water line in the forest section. So here's a few other projects that we've had recently. This this project on the left here that you see with the water line in the middle of West Mancos River. If you've been in the Southwest here, last winter we got an extreme amount of snow, so we had an extreme amount of runoff, and the river decided to, which the river used to be over here where this tree is, the river rerouted itself, as rivers do, and it rerouted itself in our access road where we have the line buried and exposed, luckily, our new line, because our old line would have broken this situation, but our new line into the middle of the Mancos River. So we had an urgent project here. Once the water flows became lower, we were able to reroute the river here and then armor up this section of road and rebuild it. So because since this was the road we used to access the intake, and it's also, we try to keep the water line inside that road to prevent impacts to non-disturbed areas. This top right picture here is the other side of the directional drill that I was talking about that cut through the north escarpment. So they're welding these pieces of stainless steel miles long so that they can pull that pipe hundreds of feet underneath this cut here up to that first picture. So if you see this scar, that's the original water line. It goes up that scar, and then it is literally strapped to the top of this escarpment here on the cables. And I also talked a little bit about Gulch Reservoir and our secondary point of intake, and that's this picture here in the bottom right. This is actually under Gulch Dam, in a section of water line that we replaced, so that we would be able, if we needed to, we could turn the intake on here and begin drawing water directly from Gulch. So Mesa Verde water in the future. You know, that's really one of my main priorities. Luckily, water and wastewater infrastructure, you know, it's so important to the Southwest, and it's important in parks. It's something that competes very well in funding sources. So I really spend a lot of time trying to identify what the oldest pieces, the pieces that break the most, and trying to prioritize those for replacement. I was talking to our long-term water operator, Brian Long, who's like I said, I've been here 35 years. And he said when he started in the early 90s, he said they were losing around 25 million gallons of water a year just to leaks that they couldn't find. And so we've spent a lot of time replacing those sections that leak. We've also spent a lot of time putting meters everywhere we can, along raw water line, along treated water lines. So we really have a good handle now on when we have a leak, which is actually pretty rare now. We don't have a whole lot of water loss in our system, but now it enables us to identify those water leaks as they come up so that we can fix them. The park's working with a lot of our local water providers, so the town of Mancos Rural Water, Montezuma County Conservancy, as well as the Mancos Conservancy, to protect the Mancos River watershed. You know, there's definitely could be threats to the watershed, along with the San Juan National Forest facilities owns most of the watershed. But you know, there's threats like always to watersheds like this. You know, it could be about proposed mine, which we haven't seen like a lot of. It could be maybe somebody even along that installs a septic system without the proper permits. But really, you know, probably the biggest threat to our watershed is probably wildfire. So the park and other land management agencies, along with the other municipal water providers, all working together to come up with plans in order to minimize those risks. We're also continuing improvements on efficiency and conservation of our water. Like I said, the metering has been huge. We've been able to really identify those leaks and where the water losses are. That helps us prioritize for put an investment, you know, to fix those leaks or replace those water lines. You know, this project that I was talking about now for the Great American Outdoors Act is replacing some of our oldest water line, and one like the Weatherville water line, for example, is one that we have a lot of leaks on. Anytime there's a leak, by the time you see a leak, how much water has came out of that leak, and then by the time you turn the water off, how much water has made it from the last valve outside of that leak. So as we can replace those with modern materials and systems and expand their lifespan, that really greatly improves our efficiency and conservation. And as I said before, just securing funding for these major infrastructure replacements, we could, get the $4 million or so every few years, or $1 million here and there, but these large infrastructure packages have been so helpful to the parks, for all of our facilities for that matter, but really in water and wastewater, really improved our ability to provide safe, plentiful drinking water to our visitors and staff and our firefighters. So with that, does anyone have any questions for me?
Well, thank you so much, Mike. And, that's why we just love this webinar series, and thank each and every one of you at the park for participating, because I personally did not know the immense scope of what goes into logistically supplying the park with water. And it's unreal, especially the expenditure each year. And if you were to, do an overhaul with all the infrastructure for the water, that's unreal. I have a question about how much water does the park produce annually?
So the park produces about 12 million gallons of water annually, mostly used for, unless we have a fire, and some stuff's used for construction, but it's mostly just for water and wastewater use, which is, like I said, a big improvement over the 25 million gallons they were losing in the early 90s.
Yeah, that was unreal. Do we have any questions from the participants? You can just leave it in the chat box.
It looks like we had a question early on. You said we were priority 37, and this person is wondering 37 out of how many?
Oh gosh, I do not have that. I do not have that on the top of my list. I can get back to the foundation and let you know. That's a good question.
Mm-hmm. And then I have a question, Mike, with across the country, everyone's always into water conservation. You don't have to live in the greater American Southwest to always be aware of what we use and so forth. So what means does the park do to ensure that in some really drought concerning seasons that you have plenty of water?
Well, I would say we don't waste a lot of water here. I mean, we're pretty efficient. We're pretty efficient with it, and I think that's a real kind of challenging question for the park. Is what happens if we ever get to that spot that our water rights are so superseded that the park can no longer draw. And obviously, the park's very important in the local economy. But we're just doing most of the things that I said. We're replacing things that leak mainly. We use a lot of all of the fixtures and stuff that we replace now are much more modern and much more sustainable than some of the historic water fixtures that people use. Things like timed valves and stuff like that. So we replace those and update them as we can. But that's a good question for all of us to battle with, is what happens when maybe that drought comes.
Well, we have a question from Sharon Graw. And are you seeing an increase in visitors? And how much of a challenge will it be to provide water in the future?
Yeah, I could do some math here. So, we obviously saw influx in visitors after COVID. This year, I haven't looked at our latest numbers. I think we're kind of around our normal 500 to 500,000. So we've never really got to a spot where we're out of water. I was looking, I think you even said so too, there's 220 acre feet yearly is what our allocation is at the water tower, right? There's 325,851 gallons per 220 acre feet. So I'm not exactly sure how much that is, but I think we have the we still have some buffer, and if we're making 12 million gallons a year, I think we still have some buffer into the future. But I think that what we're really hinged on that is we got saved this year. We had a couple of really bad drought years where there was a lot of talk of different water rights issues, and then we had 150% winter that really brought us back or saved us for the meantime. So we'll see what this one brings.
Okay, thank you. And we have a question from Caroline Fisher. If a government shutdown takes place, does this impact the water service in the park?
It does not. And actually, thanks for reminding me. I was going to talk a little bit about that when I was talking about our operators. So our operators are very essential. They work 7 days a week. So they would be on that essential list of government employees because that's a life health safety thing. So anything that's life health safety, we staff that regardless of a government shutdown. So they will be working while some other people are not.
And we have a question from Denise Robertson. If we were to fill the 2.8 million gallon, she put talks, but I'm sure you know what she's referencing. How many days would that serve for visitors in the park?
Well, that's a really hard question too, because we have, like most parks, we're such a seasonal system. So we ramp way up in the summertime, to where we're using our most amount of water, which I don't have the number for you here. And then we ramp down to the wintertime where we're shutting down a lot of these systems. So I could get you a number on what our highest day is and what our lowest day is, but it's just really hard to, you have to do the formula to see what that is for day. But I don't think that would give you a good grasp on a yearly, because we're such a peak to valley type of operation.
Okay, and we have a question from Mary Eckberg. What does the park do for recycling?
So the park recycles everything that we can recycle in the local area. So we recycle aluminum, we recycle cardboard, and I'm not the one who manages all this, but I don't believe we have a local plastic recycler. And we also recycle things like all the scrap metal in the park. We recycle light bulbs, we recycle batteries. But as far as like that larger scale stuff, I think it's mostly aluminum and what was the other one I said? Aluminum and cardboard.
Thank you. And a question from James A. Mason. Are there any cisterns in the park?
Well, James probably knows if this is James Mason.
Yes.
But so there is cisterns in the park, and I'm probably not the best historian of cisterns. That would probably be Lizzie Dickey would be a better person to speak on that. But yes, there were cisterns for storage of water in the park, I believe, from some of the rainwater. And there's actually some wildfire cisterns in the park that not many people know about that was used once the park had water, but they didn't have the storage for firefighting capabilities, so they installed some cisterns to store that
water. Well, we have a lot of questions coming in. So, Mike, this is really interesting. I think water is always, it's our basic need, right? So it's always of such interest, and especially at this magnitude with the infrastructure. This question is from Joe. How do you know if you have leaks? Do you have smart meters to measure the branching flows of water in the distribution system?
So we have kind of smart meters. We have meters that we don't have to get out and read. So we don't have to physically go over to them. We can basically drive around and with a computer and a piece of technology that can pick up the readings from those meters. And so, usually that's a monthly thing. And so that's, for the most part, it's probably monthly. If we're losing a lot of water, we know, because the guys are saying, well, hey, how come we can't keep the tanks full? We got a 2 million gallon tank, and when we lost a foot of water, and if they do the math on that, and they realize it's a lot of water. So for small leaks, it's mostly our monthly meter reading process that we able to get.
All right, and a question from Ed Robb. Do you shut off the water to the winter closed areas of the park? If so, is it a huge task to restart when those areas reopen?
Yes, Yes, we do. So we shop water to Weatherall, and we provide water to our other places that have a very low use. So like Fargo, the largest also, we have a few residents there. So yeah, it is a lot of work because the treatment process for a lot of water is different than a little bit of water, and it's also we winterize things and then turning them back on. Also, it really sets a measure for a different type of testing as well. So it's one thing if you have a system that's been in place and you're doing your weekly or monthly test, but there's a whole nother startup procedure and standard operating procedure with tests that you have to recommission a system seasonally.
Wonderful. Well, thank you everyone for your wonderful questions and for your interest. Shannon, do you have anything you would like to say?
Well, first I was going to ask Mike, do you recycle any of the water is that's used? I think that's what maybe our earlier question was referring to more.
So no, we don't recycle any water. No, we don't recycle any water. We don't have any kind of like a secondary use. I know some places maybe have like a gray water service. We don't have that. We do have a electric turbine that's in our water system, and we use. And I didn't design this. We don't use the gravity flow from the water, but when we pump water, we we turn a renewable energy turbine that offsets the cost of our water. Along with, we made some pretty big infrastructure investments in solar at our water treatment plant. So that also helps offset the cost of the electricity that we use to pump it.
Well, thank you. Thanks for answering that question. I don't have anything else to say except thank yous. Thank you to everyone for joining us. Thank you to Mike for your very informative presentation. I think you might hold the record for number of questions asked. And I know that I haven't seen any that required a calculator before, so thank you. And of course, thank you to Monica, as always, for moderating our fantastic webinar series. We just want to say thanks again to everyone for joining, and thanks to everyone for your support. We couldn't do this without you. Have a wonderful rest of the day and enjoy your holiday.
Thank you.